Hello again, everybody, and welcome back. This chapter on potential energy and conservation of energy, we've finally gotten to the spot where we actually define what potential energy is. The adjective potential is actually a very good descriptor of potential energy. Potential energy is, we oftentimes say in physical science classes, stored energy, or it represents the potential to do some work. And in fact, that's going to be our definition of potential energy. Work done by a conservative force, that is like gravity or springs, all right, indicates a negative change in potential energy. For example, if you have an object, we'll say you have a ball, and you raise it up off the ground. Okay, so here's the ground right here, and here's your ball. It's a meter off the ground. Okay, it has some potential energy. It has the potential to fall to the ground. But once it does that, to here it's got what we call potential energy, and we define that as U. You might say, why don't you call it P? Well, we've got P for power right there. So our unit for our symbol for potential energy is a capital U. It has potential to fall right here. But once it does, once gravity pulls it to the ground and your ball is now at the ground, it has lost its potential to fall anywhere because it's already fallen. So gravity does some work bringing it down to the ground, but once that work has been done, okay, that work represents a loss of potential energy. So we've got a negative change in our potential energy on the ball that has already fallen. All right, so that's the relationship between gravity and potential energy, especially when regarding a conservative force. All right, if it has the potential to fall, that's great. When it has the potential to do some work, that's wonderful. But once it does, once the work is carried out by that conservative force right there, it now no longer has the ability to fall, and so it has lost some potential energy. It's a negative change in potential energy. The nice thing about this is that this is a delta. This is a change sign right here, which means it's a difference between the beginning position and the final position. All right, now this right here might be, like I said, 1 meter. Let me redraw that right there. 1.0 meters going from here down to the ground. All right, that's all we care about in this kind of local area, the distance from here to here. You may be hundreds of meters above sea level. That doesn't really matter. All you care about is the change in your position from here to here. All right, so what that means is you can choose wherever you want to place where potential energy equals 0. Right here, does it have the potential to fall anymore? Well, not according to the ground right here. It's already on the ground. But if you're some distance above sea level, I guess somewhere it could fall back down to sea level. But you don't care about that. You care about just your local area right here. So we could say that, let me go back to my black here, that this level right here is 0, and that this level right above here is 1.0 meters. And so this ball has undergone a change of negative 1.0 meters when it's displaced downwards. All right, so that's the point with dealing with potential energy and position especially. We talk about position with regards to potential energy because usually the conservative force we're dealing with is gravity. And depending on how high you raise something up, how high you displace it, that determines how much potential it has to do some work. All right, so gravitational energy is the one we're going to be talking about a lot. If you have an object, all right, and it is on the ground, let's go back to our ball for a second. All right, it is on the ground right here, and work has already been done, and it's lost potential energy. Okay, I'll just fill that in there like that. Okay, we can we can define the work that gravity does as being it was previously here and it displaced downwards. All right, work is a force mg, gravity pulling down on it, right, times a distance. It moves through distance y. Okay, if we want to put energy back into that or do work against gravity, we can bring the ball from that position back up to here. All right, so if we do that, we apply a force upwards of mg. We move it through distance y, right? And it now has the ability to fall again, all right? So the work done by gravity, right here, is a conservative work, right? Gravity is conservative. You work against gravity, gravity will then work against you, or you do work for gravity, gravity will work then for you. Gravity represents a negative change in potential energy. When it falls from here to here, it loses potential energy. Here, you put potential energy back into it by working against gravity, and then gravity will then be ready to work for you to bring it back down to the earth. So wherever we have change, it is final minus initial, right? But if it's negative change, then that means it's initial minus final. And so since all this equals the work done by gravity, we can say that the initial potential energy minus the final potential energy equals that work that is done by gravity. Force times distance. Here's our force right there. There's our distance that it moves through. So mgy, or some people say mgh, h being for height. You could use either, honestly. But this right here, this negative change in potential energy equaling mgy, that's going to be our statement down here at the bottom that describes how we calculate potential energy. Our initial potential energy, all right, plus some work done over distance, equals some work done over the distance, plus your final potential energy. Okay, so all of our energy is accounted for. Let's say it moves, I don't know, initially it's up here and it's got a certain number of joules, so I'll say right there, okay? And it moves halfway down. It still has some potential energy, so it still has some final potential energy, but that halfway down represents, so going from here to here, represents that mgy, right? Gravity creating the force mg times this distance y right here. So this is our u initial, here's our u final, and I don't know what that was right there, our potential energy u final. And this moving down is that mgy, the work that gravity does. Mgy. Sorry that's so small in there, because I could have written it bigger at the bottom. But we're going to be illustrating this in some examples in just a little bit. Okay? So gravitational potential energy, the ability that gravity has to do work, is going to be represented by mgy. Now remember that we said before that you can put your base level wherever you want. Remember I said that you can, even though you may be several hundred meters above sea level, all you care about is your local environment right now. So if you call this 0, okay, that level 0 right there, then that means if you take a ball or any object and you take it and you raise it up to some height, you're putting potential energy into that. The gravitational potential energy that it has is going to be equal to the force that is applied to bring that up. What force do you have to apply to raise a ball up in the air? Well, you've got to apply a force of mg, whatever the mass of the ball is, times gravity. You've got to apply that force over this distance y right here, from there to there. And so that's why the gravitational potential energy that an object has is going to be mgy. And that's what we have boxed off right here. Like I said, some people say mgh. H can represent height, if you want to call it that. mgy, mgh. One thing to keep in mind is that on the surface of the Earth, you're already some height away from Earth's center of gravity. You're the Earth's radius away from Earth's center of gravity. So for small scale things, height can just be the same thing as y. But keep in mind that really you're already some very, very large height away from Earth's center of gravity. So we'll kind of split hairs on that a little bit later. But for now, what I'm going to say is that you can just call this mgy or mgh, and the problems will work out. It'll it'll work out fine. All right, I'm going to call it quits on this segment right here and do example 8.3 in the next one. So, well, thank you for following along, and I'll see you on that one.